Yeah, at 30. And then once
Hello,
you
everyone.
30,
Mr. Minnick's my name.
15,
Math is my game.
15,
I'd like to start off this
30,
particular
15,
lesson on the
15,
unit circle.
15,
This is the
30,
final
30,
unit circle
15,
exploratory lesson. In other words, all the final bit of
15,
theory we need to know, and then we'll just be
30.
applying it after this if there's any more videos to follow. There's a shout out to Fergie, and also a shout out to, how do I say that again?
So
James Dennis Pietzu gets a shout out.
Y'all can
We love you, Fergie.
see this clearly. Hopefully I didn't shake
the future
too much.
Mr. Minnick, probably back
hopefully I
taking
made
notes,
sense.
Answering questions. Gets a shout out as well. So here we
any
go. We need to talk about this.
I guess leave
Now,
comments or something.
earlier today,
this is my first
we seem
video,
to have a great
so
difficulty with that concept.
I really
The first thing that came out of people's mouth was, well, it's negative. No, it's not. If you go back to your notes on negative exponents, I made a very bold statement that negative exponents don't make a quantity negative.
And I mean, teachers sometimes they'll make you draw 2 circles and then remember
it's not 1.
The 2 unit circles. And
it's not 0. Let's explore. Let's explore something. It's not I. It's not pi. Let's explore something.
And you'll
computers are based on powers of 2, and powers of 2 should be very familiar with us.
The fastest time I drew unit circles.
Now, I had a college professor at Youngstown State. Did I ever tell you about him?
3 minutes.
He looked like the guy that has the wine flask on his side from Virtual Fighter. You know who I'm talking about? Anyway, the man was about 5'2". He looked Asian, but his last name was like Smith or something like that. And please don't think I'm making fun of people. I'm just sharing this story. Okay? He had a very thick Asian accent. I thought he was like a ninja in his former life. Because he would say this. He would say, "Okay, class, today we learn about computer, okay? Fine." And that's how he talked. And he would say this. He would say, "In computer, everything is a power of 2, okay? Any questions?
Patterns and tricks that will help you remember it.
2 to the first power
take a look at this.
Equals, and everybody say?
These are
2. Good, excellent.
This is the x-axis.
And 2 to the power 4 equal?
These 2 lines touch the circle
16.
At 4 points.
Good. Now,
right,
I skip one.
top,
let me go get 2
bottom.
to the power of 2,
When
okay?
2
to the power of 2 is?
We always start here on the right side.
4, okay?
And we
fine.
move up.
And 2 cubed, or 2 to the power of 3 is?
All the way
is
around.
8.
Let's look at the 4 angles you get.
Let's take a look for a minute.
This point, this point, this point, and this
2 to bigger power multiplied by 2, okay? Fine.
So this
2 to the power 0
is 0 because that's where we're starting.
Then
if we move up and rotate counterclockwise.
1. Good. We finally get it. 1.
These angles are in radians.
Going
degrees.
This way.
Pi in them.
2 to smaller power. Divide by 2. Yes.
We have the angle pi.
2 to the power negative 1 is.
So the whole circle will be 2 times that, 2 pi.
1/2.
Another quarter of the way through the circle, we have the angle.
So let's try this again. What's a to the negative first power?
Through the circle was pi over 2. So 3/4 of the way around the circle is 3 pi.
1 over a. Winner, chicken dinner.
Circle. We get.
So far, so good.
Now we've come full circle.
Now what this means is it's weird because it's a numeric inverse. It's a numeric inverse. And there is an R word that means the same as a numeric inverse. What R word am I thinking of?
Okay.
Reciprocal, nice. Good. Reciprocal. Okay. So
equal parts.
My advanced class has studied inverse functions.
1/4.
And what I want to show you is something that a lot of people get this idea confused. Are any of you taking trig this year? Probably not. Anybody taking trig next year? This will help you with that. If we look at this, sine raised to the negative first power of theta. A lot of people screw this up bad.
Then 7 pi over 4.
That is an inverse trig function. Now my advanced class knows what happens if you take the inverse of a function. They kind of cancel each other out. So real quick, I'm just going to write this. You don't need to write this, but real quick, I'm just going to kind of write. If you took the sine inverse of the sine of theta, that would actually simplify to be just theta. And that's useful when you solve equations and are trying to find unknown angles, okay? But that's an inverse trigonometric function.
Down here, 7 pi over 6. And down here, 11 pi.
Does not mean 1 over the sine of theta. I need to be as clear as I can about that. If you have sine with an exponent of -1 and then theta, that doesn't mean 1 over the sine of theta. And you're probably scratching your head, but wait a minute. A to the negative first power was 1 over a. Yeah, it was. You're right. In that notation, using a superscript of -1, in this particular context, this superscript is indicating that it's an inverse function. It's not indicating that we're taking a number and finding its numeric inverse. Okay. So it's kind of confusing. So you might ask the question then, well, what is 1 over the sine of theta? What does that equal? Here's where we're going to introduce 3 brand new trig functions. You ready for it? Whoever named these, I really wish that I could meet them. I'm not a violent person. Earlier today, I went and looked up the signs of the zodiac. I don't buy into that, but there's some coincidence. Whoa, where'd you come from? There's some coincidence here. They say that Libras are diplomatic and graceful. I don't know about the graceful part. Peaceful, idealistic, and hospitable. Anyway, where was I going with that? Oh, the person that named these. I'd like to take them into a dark alley and give them a couple good ones. And what I mean by that is punch them in the face hard and rearrange their face a little bit. This is silly. The fact that 1 over the sine starts with an S, don't you think that what this is should start with an S? But it doesn't. It starts with a C. It's actually called the Cosecant. It's abbreviated as the CSC of theta. So if that wasn't confusing enough, 1 over the cosine of theta, you would expect that to start with the C, right? But anyway, this one is called the secant or secant. Some people pronounce that different than I do. Some people call it the secant, whatever. I don't know. It is what it is. So this has nothing to do with basketball or football or the Southeast Conference. Some Florida State fans might know what the SEC is, but it's SEC of theta. Okay. And finally, we're going to have one of these for the tangent as well. So 1 over the tangent. This one actually makes sense. The name of this one is actually sensible. This one is called the cotangent, and is abbreviated COT. Okay. So those are basically 3 new trig identities that in trigonometry you'll study. When we apply this to the unit circle, you're going to be evaluating those functions. They're new functions, and all they are, it's real simple. They're just numeric inverses of what the sine's value is. So we'll tie this together here in a minute. What we need to do now then is look at a few numbers, and let's look at some inverses. Okay? So here's the number. In the left column, I'm going to have 2 columns. Here's the number, and in the right side, I'll say here's its numeric inverse, or its reciprocal. It's reciprocal. Okay? In the general case with radicals, does anybody remember what the inverse or the reciprocal of rad A is? We just saw this yesterday. It's rad A over A. Okay, that's going to help us quite a bit. I don't know if you've noticed this, but there's only a finite number of things, finite number of values that these trig functions take on. Check this out. Let's start with the square root of 2 over 2. What would the square root of 2 over 2's reciprocal be? Wouldn't the first one be a over the square root? The first one is 1 over the square root of a, but then we have to rationalize it like so. And when we rationalize it, we get square root of a over the square root of a squared, which is the square root of a over a. Okay. Because remember, we're not allowed to have radicals in the denominator. That's bad. You do start off with finding the reciprocal. You do start off with a over 1, and then it becomes this, but we're not allowed to have radicals in the denominator. Okay. So what would the reciprocal of rad 2 over 2 be then? Just rad 2. Just rad 2. How are we doing so far, okay? Now, we also had a rad 3 show up when we got into the tangents, didn't we? What's the reciprocal of rad 3? Rad 3 over 3. And what's the reciprocal of rad 3 over 3? Rad 3, right? Now, what's the reciprocal of 1/2? 2, good. I better change colors here. What's the reciprocal of 1? It's still 1. This next one, these next two are the ones that get people. Be careful with this one. If you're finding the reciprocal of 0, you got to think back for a second, and I know that's hard for some of us to do sometimes. It's really 0 divided by 1. It's its reciprocal. It's not 1. It's not 0. It's undefined. It's undefined because it's really 1 over 0, and it is undefined then. Okay? Now, when we talked about tangents, some of the tangents were undefined, right? Well, what's the reciprocal of undefined? 0. Reciprocals are reciprocals of each other, right? So undefined's reciprocal is 0. This last one, this is the worst of all of them. It's the most scary looking thing you'd ever want to see. Square root of 3 over 2. Remember, you're not allowed to have radicals in the denominator, right? So if we invert this, it's going to be 2 over the square root of 3. But don't we have to rationalize the denominator? So we multiply by rad 3 over rad 3, which gives us 2 rad 3 over rad 3 times 3. And 3 times 3 is 9, and the square root of 9 is 3. So what this is going to be is 2 rad 3 over 3. That's probably the worst for people to memorize. Okay. Wow, that's a lot of stuff. So let's see how this all ties in with the unit circle. When you take the unit circle challenge, I might ask you to evaluate the secant of 3 pi over 4. Some of you are going to know it right off the bat. I know that it's negative rad 2. Wait a minute. No, it's positive rad 2. I'm sorry. I stand corrected. How did I know that? What do you do to figure this out? You got to go in the unit circle to where 3/4 pi is. Where's that at? It's in the second quadrant, right in the middle, right? And what are the coordinates there? Negative rad 2 over 2 and rad 2 over 2, right? Now, how does the secant compare to what? The secant is the numeric inverse of the... It actually is negative rad 2. Isn't the secant the numeric inverse of the cosine? So the cosine of 3 pi over 4 is this x-coordinate right here, right? So that's negative rad 2 over 2. But the secant is the numeric inverse of that. Well, what's the numeric inverse or the reciprocal of that? What I said the first time, isn't it negative rad 2? Okay. These are the things that you're going to be doing on the unit circle challenge. If you don't believe me, I'll show you the pre-made unit circle thing I have here in just a minute. I'm going to go ahead and save these notes. Save them to this week. What would be a good name for this? I'm going to make it a PDF so I can upload it. Unit circle, CSC, SEC, COT. There we go. It's good enough. So here's this unit circle interactive board that I've got, and this is how I'm going to do this unit circle challenge. I'll spin the spinner. That looks like 2 pi over 3 to me. Fair enough? So 2 pi over 3. So before we even do any of this, we probably ought to be thinking about what the coordinates there are. The coordinates there, if you're not sure, we don't go over as far as we had to go down, right? So the x-coordinate is negative 1/2. Good. The x-coordinate's negative 1/2. The y-coordinate is rad 3 over 2. Good. And what about the tangent up there? The tangent's negative rad 3. Good. We're getting this. So the next thing I'll do is roll the number cube. Let me turn the volume up so you can hear it. I like this because it's in Espanol.
3.
Did you hear it? It's a tres. Tres. Tres is tangent. So what is the tangent at 2 pi over 3? Negative rad 3. We already got it. We didn't have to do any work. Maybe another function comes up. Maybe
4.
we're going to find the CSC. So if we wanted to find the cosecant at 2 pi over 3, what we're going to do is, remember, that's the numeric inverse of the sine, and the sine is the x or the y coordinate. Which one? The sine is the y coordinate, and the y coordinate's rad 3 over 2, so we want the reciprocal of rad 3 over 2. So that would be that nasty looking one. The 2 rad 3 over 3. That's what you're going to be doing next week in that unit circle challenge. Let's try a couple more. And then that'll be that for today. So if I spin the spinner again, now we're looking at, let's spin it again. It's kind of hard to tell where that was. 0, good. At 0,
2.
we want the cosine. Cosine of 0 is? X coordinate? 1. Let's try again.
5.
Oh, the secant at pi over 4. The secant at pi over 4. So we want the numeric inverse or the reciprocal of what the cosine is. Isn't the cosine rad 2 over 2? And the numeric inverse of rad 2 over 2 is? Rad 2. Rad 2. So a couple more.
4.
Cosecant. Okay, so this time it's the cosecant at 3 pi over 4. So we need to know what the sine. Hey, isn't this the same as the last one? Well, hold on. The sine is positive rad 2 over 2, and the cosecant's the 1 over the sine. So it's going to be the same. It's going to be rad 2 again.
6.
Let's call that 11 pi over 6. So at 11 pi over 6, we want the cotangent. So we got to know what the tangent is down there. It's got a 6 in it, so isn't it a 3 and a 3? So it's negative rad 3 over 3 is the tangent, but we want the reciprocal of negative rad 3 over 3. So it would be negative rad 3. That's what we're going to be doing next week. It's been real. It's been fun. One last minute for shout-outs. Anybody got one? Madison Geddes gets a shout-out. Anybody else? Well, I hope everybody has a good weekend. Good luck on the rest of your quizzes and tests and all that. See ya. Good.